In this video, we're going to continue topic 2.5 and 2.6, looking at basic derivatives, and we've moved on to how they relate to tangent lines. So in example 9, we are finding the locations of horizontal tangent lines. So let's think about what that means. Horizontal tangent line. So if I've got a function and I've got a horizontal tangent line, think about that. The slope of that tangent line has to be equal to 0. So when I'm looking at horizontal tangent lines, I already know my slope value is 0, guarantees a slope of 0. So at what point does the graph of y equals x squared plus 4x have a horizontal tangent line? So the only way I know how to do that is I'm going to start by taking the derivative to get the slope, and then I'm going to set that equal to 0. So y prime equals, I'm going to bring the 2 in front, so I've got 2x, I'm subtracting 1 off the exponent, so to the first power. And then I'm going to bring the invisible 1 in front, so 1 times 4 is 4. Subtract 1 off the exponent, and I get x to the 0 power, which is just 0, or sorry, just 1. And then the derivative of this number would be 0, so I'm not going to write that down. All right, I am going to set this equal to 0. So 2x plus 4 equals 0, because the slope of a horizontal is equal to 0, and I just got the slope. I'm going to evaluate that for x. So 2x equals -4, x equals -2. And then I'm going to take this, that's the x value where it is horizontal, but it wanted me to do a point. So I need to go back into my original function and plug in the -2. I am going to tell the grader that I am plugging in a -2 by saying y of -2 equals 2 squared, or -2 squared, plus 4 times -2 minus 1. So all I did was plug into here. -2 squared is 4. -4 times -2 is 8 minus 1. So we've got 12 minus 1, which is not what I wanted it to be. 8, 4, oh, I had a typo, didn't I? Look at this. So right in here, it was supposed to be plus 4. So that made this -8 minus 1. So we've got 4 minus 8 is -4 minus 1 is -5. So and then my official point, you need to rewrite it as -2, -5, or tell me y of -2 equals -5. This is an okay way to write a point. You'll probably see it more like that in calculus than you will with the parentheses. Finally, example 10, we have to ensure a tangency to a given line. So they love asking questions like this where they give you like a constant that's missing. So given the function f of x equals x cubed plus k of x, and the line y equals 6x minus 2, find the value of k so that the line is tangent to the function. So if the line is tangent to this function here, I know that tangent lines have the same slope, would have the slope of this, okay? So let me say that again. I know that the derivative would have to equal this slope, okay? So I'm going to find the derivative of this and set it equal to that slope, and that was going to hopefully help me find that value of k. So I'm going to start by taking f prime of x equals, and I'm going to bring the 3 in front, so 3x. I'm subtracting 1 from the exponent squared. And then this is going to be 1 to the front. 1 times k is k. I'm subtracting 1 from the exponent, so it's x to the 0 power. So that's my derivative. So I'm going to take that derivative and set it equal to the slope in this line because I already know the slope. So 3x squared plus k equals 6. I know. Oh, wait. I'm not doing it right. Find the value of k since the line is tangent. So actually, I don't want just the slope. I want the entire line. So we want it. So this line here that slope is equivalent to that line there. So 6x minus 2. So I'm going to use that to solve for k. So let's go ahead and see if we can get that simplified. No. Nope, I was right before. I'm sorry. I'm looking at the notes, and so I'm going to do this derivative equal to the slope. The problem is that I have two variables, okay? So because I have two variables, I need two equations. It's called a systems of equations. So I am going to also now set the two functions equal to each other because we want to know where those two functions are equal to each other because they're equal to each other somewhere. So I'm going to set this equal to this, and that's going to be my second equation. So x cubed plus kx equals 6x minus 2. So let me just recap what we've done. We took the derivative, we set it equal to the slope of the line, okay, because the derivative is the slope. Then I noticed I had two variables, which means I need a second equation. To get the second equation, I know at some point I want this function equal to that tangent line. It's only going to be equal in one value at one little point, but I need it equal. So that's where I got the second equation from. So I'm going to choose to use the substitution method. So that means I'm going to bring this over to the other side by subtracting. So k equals negative 3x squared plus 6. So now I'm going to use that and substitute it in for k in this equation. So x cubed plus parentheses x equals 6x minus 2. I'm going to substitute this in. That was a poor color choice. Substitute that in, so I get 3x squared plus 6. And then I'm going to go ahead and try to solve for x. So we have x cubed plus, I'm going to distribute this x in. So 3x cubed plus 6x equals 6x minus 2. Well, it looks like I can combine these two together, so that's going to give me 4x cubed. If I took and subtracted this 6x from the other side, so I'd have 6x minus 6x, it's going to be 0, so the 6x's are going to go away. And we just got negative 2. And then I am going to, something went wrong somewhere. Did I lose a sign somewhere? Oh, I see what I did wrong. Okay, check it out. I missed, this was supposed to be a negative 3. So that's a negative 3, that's a negative 3, which would make it 1 minus negative 3, which is a lot better than what we were having before, actually. So that's going to make it negative 2. Now let's divide that negative 2 to the other side. So when I divide that negative 2 to the other side, I get x cubed equals 1, which is so much better than the fraction. So take the cubed root, x equals the cubed root of 1. So we're supposed to still find, we haven't found the value of k yet, so it's the never-ending problem. We now need to take that and plug that back in somewhere. I'm going to choose to plug it back into this equation here. So we have k equals negative 3 something squared plus 6. Excuse me. I'm going to plug in the 1. So we've got k equals negative 3 times 1 squared, which is 1, plus 6. So negative 3 times 1 is negative 3. Negative 3 plus 6 is 3. So k is equal to 3.